whether or not this is a good plot depends on what I'm trying to do with it. If I just want a quick sanity check on whether or not this is a good linear fit, I think I've got that. We could go forward with linear regression. If I were trying to use this to give information to someone else, I don't think this is a good plot. You can't just include a plot that looks like this in a report and expect it to help anyone. So I definitely think we should add some features. Let's add a title real quick. So I'm just going to search title on my matplotlib documentation. So there are a couple of different matches. So let's see, a centered title. I could do a title label. Yes, we can do that one. Let's do, and what does it need? Soup title just needs the keyword, the actual title. Let's see, click on that. Yep, title text string. That's what the argument T is for. So can do plt.souptitle Usain Bolt's 2009 100-meter run. And I would also like to label the axes. I think it's important to give some words here. So if I go back to the main page and I search for, do the find command for label, there are a lot, so I'm going to search through these pretty quickly. Okay, X label, set the label for the X axis. I would like that, so let's do plt.xlabel time in seconds. And I'm guessing that plt_ylabel does the same thing, our position in meters. There's one more command that I throw at the end, plt.show. So let's hit Shift Enter here. And you see now we have a title, we have labels. I kind of like that feature. Visually from the scatter plot that there's a pretty good linear relationship. Although we might see a slight curve, I think it's a pretty linear relationship. So let's look at the correlation coefficient that we've just been talking about. And I can do this with bolt df time.corr. This is CORR is a built-in command in pandas that finds correlations between things. Bolt df position, and this should give me what I want. Yes, so this tells me the correlation between time and position. That is extremely strong, 0.99. That says there's a very strong positive linear relationship. That doesn't mean I don't have to worry about this curve at all, but it certainly suggests that a linear model is reasonable. Okay, so I'm going to use the scikit-learn package, abbreviated sklearn, and instead of importing all of sklearn, which is huge, I'm just going to import the commands that I'm using. I'm also going to import something called numpy, and there's a reason for that. I might need that in a minute. So let me import numpy as np. And what I'm going to do is create a linear regression object. So you should think of this as like a robot that knows how to do things related to linear regression. And I just purchased one, and I'm going to ask it to do the things that it knows how to do. And one of the things it knows how to do is fit. So it will take an X of training data and a Y of target values, and it will come up with a fit of the model X to Y. So my input here is going to be my bolt df time, my bolt df position. I try to do that, and something happens and it's not good. It says expected 2D array got 1D array instead. Reshape your data using either array.reshape -1 1. And I'm going to try that. It tells me the issue is that this first entry has the wrong shape. So I'm just going to do what it says. Still get an error. Okay, this is a different error, so that's progress. It says the series object has no attribute reshape. So I am going to Google reshape a NumPy series, and there's a little bit, what's happening here that's a little bit weird is it's the column is actually a series object, so columns in data frames have series types, but arrays can be reshaped. So I need some way to get from my series type to an array. And let's see, okay, Stack Overflow is a really good place to look for questions. So someone is trying to do what I am trying to do and reshape a series, and it's not working. So, oh, we could call it on the values array of the. So it looks like if I take my series and do dot values dot reshape, that will work. This is kind of hacky, but sometimes that's how these things work. Voila. So now I have a linear regression. My LM has now been fit. So I now have a linear regression that fits position to time. And I want to see what the pieces of that are. So a couple of things it can do. It can get a coefs. So it has a coef attribute, which is an array. And it also has an intercept, which is for the. So what we're trying to do here, or let me remind you, we are trying to fit a model of the form y equals wx plus b, or in this case it would actually be position equals w times time plus b. And now what we're interested in, what are the w and the b? So w is going to be a coefficient, and b is going to be the intercept in our terminology. So if I look at lm.coefs, spell it wrong, no, coef, lm coef, I see that the coefficient is 10.9006, and if I look at lm.intercept, negative 8.02, so the model, the linear model that we have developed is position equals 10.9006 times time minus 8.0211.